Hey everyone, welcome back to my YouTube channel where I will be doing tutoring videos. Today's tutoring video marks the introduction of a new topic, derivatives. This is also in AP Calculus, both AB and BC. So to start off with, what is a derivative? The derivative just represents the rate of change. And when you think of rate of change, you may have heard of average rate of change, which can be expressed by the slope from one point to another. So you might be more used to this being rise over run from previous algebra classes. So m is equal to rise over run. The instantaneous rate of change is just the tangent line at a specific point. So for example, a car speedometer will show you the instantaneous change, so the speed at any given moment. But how do we calculate this instantaneous rate of change? So to start off with, we'll graph any random function. We'll take x squared, and that is the wrong color for my graph, but it does not matter. So we can start at any point. Let's just call this x. And then we'll call this point over here x plus h, so that the distance between these 2 points is h. So that would make this f of x and this f of x plus h. So your normal formula for a slope would just be y2 minus y1 over x2 minus x1. And you might be used to y2 being the point on the right and x2 being the point on the left. And so we'll stick with that for now. So in this case, y2 would be f of x plus h over x plus h, and y2 would be f of x plus h, x2 would be x plus h, and then we have to subtract y1 and x1 on the numerator and denominator. So we subtract f of x and x. And if we were to simplify this, we would get f of x plus h minus f of x all over h. But we don't exactly know what h is, and this only really gives us an average rate of change. But if we were to bring f of x plus h closer to 0, then your average rate of change would be closer to this tangent line. This is what we are meant to get, for example. But our average rate of change would get closer and closer until the distance between these 2 points are 0. Once the distance between these 2 points is 0, we get an actual tangent line, or the slope of the tangent line. And this slope of the tangent line is the derivative. So the derivative is just the rate of change of a function, or instantaneous slope. So how would we express this mathematically? So we already have this formula to find out the slope. And now all we need to really do is find out what this approaches as this distance decreases. So as h keeps getting smaller and smaller, this keeps getting closer and closer to our actual derivative. So this is our formula for a derivative, where f of x can be anything. And we can normally, if f of x is our original function, the derivative of f of x can be expressed in multiple ways. One of the very common ways is f prime of x, or d over dx of f of x, although this is not really what you would, this is not as common as the one on the left. Or if your original function is y, then dy over dx is very common, and to a lesser extent y prime is also used. And so this derivative will give us the rate of change of any function. And you can even do this for relations, so something that isn't actually a function by a normal definition, something like the equation for a circle, you can still find the derivative of it at a certain point. And so we'll start off by finding the derivative of the function y equals x. So if you use this formula that we got before, dy over dx is equal to the limit of f of x plus h minus f of x at all over h as h approaches 0. Then we can start by finding our derivative. So f of x in this case would just be x. But what would f of x plus h be? So to find f of x plus h, replace all instances of x with x plus h. So in this case, there's only x, so you just replace it with x plus h. So you have x plus h minus x all over h. And so once you simplify this, you get h over h. And you can't evaluate this limit just yet, because if you do, you get 0 over 0. But as soon as you can factor a h out of the numerator, then you know you're doing it right. So in this case, h and h cancel out. So you would just get 1. So the derivative of the function x is just equal to 1. And so let's try it with a different function. Let's pick a constant this time. F of x is equal to 2. So f prime of x, we'll use that instead, is equal to the limit of f of x plus h minus f of x, all over h as h approaches 0. And since there's no x in this function over here, you can't really replace x with x plus h. So f of x plus h in this case would still be 2. And then f of x is also 2. And don't forget to copy the limit as h approaches 0 thing on each step, because you still haven't evaluated the limit yet. So you have the limit of 0 over h as h approaches 0. But we know that this just becomes 0 because it's the numerator. And so the derivative of the function f of x equals 2 is equal to 0. In fact, the derivative of any constant, you can have negative 1, 5.5, 1 million, and negative 1 million. They all have the same derivative, which is 0. And this makes sense when you look at it graphically, because your constant line is a horizontal one, and your rate of change from here to there, it doesn't change at all. So rise equals 0, and no matter what your run is, 0 over anything is still equal to 0. So it makes a lot of sense for us to know that this derivative will be 0. And likewise, we can find the derivative for anything. Y equals x plus 5 will have the same derivative, because any line will always have a constant slope. Y equals x plus 5 and y equals x plus 2 have the same derivative because the slope is constant. And a constant slope means a constant derivative. But now we'll start with something more difficult, quadratic. So take f of x as x squared. That would mean that f prime of x is the limit of f of x plus h minus f of x all over h as h approaches 0. So since f of x is x squared, f of x plus h is x plus h all squared. And then you subtract x squared and have h here. So what you would need to do is expand these brackets over here. So you get x squared plus 2xh plus h squared minus x squared all over h. And I should really be remembering to write this limit sign each step. So this x squared and that x squared cancel out. So the limit of h of this function as h approaches 0 would just look like this: 2xh plus h squared all over h. And if you see on the numerator, every single term has h in it. So you can just factor out a h and cancel them out. So on this next line, you would get 2x plus h as h approaches 0. And now we should be evaluating our limit. So as 2x plus h approaches 0, this will just be gone, and you will be left with 2x. So the derivative of x squared is equal to 2x. Next time, I'll be going over some basic properties of continuity and differentiability. And until then, stay tuned and keep improving in math. Thank you for watching.